Hi, and welcome to Proof That Agile Works, from spacecraft to supercomputers. So the first story that we're going to talk about in terms of Proof That Agile Works is Skunkworks. Skunkworks was the program that produced the P-80 Shooting Star, the first jet fighter. This was a program that was developed under Lockheed Martin in World War II. Kelly Johnson, the chief architect for this new aircraft, was given the task of building the first jet fighter in 1943. And this had never been done before. So in order to do this, he took his whole team and he put them into a tent. And they came out with a working prototype within 143 days, the first working model. The idea that we could produce an aircraft of a brand new quality that could be a jet fighter that could go into battle within less than half a year is crazy. But it was done back in World War II using Kelly Johnson's approach. And when we look at the key success factors, what we see is that a lot of these success factors actually match what we propose is the right way to do work in Agile. In fact, when we take a look at the key tenets, we see that he had strong, self-directed, cross-functional teams, that he had owners and vendors on the same team, and they trusted each other. They emphasized that. They were willing to manage and respond to change because, remember, they had never done this before. They had never built a jet fighter. And as a result, they would have to minimize their reports but still record the important work. This is because so much work was being done concurrently that everyone in the tent was allowed to come in and adjust the architecture as learning and improvement occurred. And finally, with this incremental development and self-testing approach, they were able to quickly identify if they were getting a working product. This required an enormous amount of trust between the Air Force and Lockheed Martin and Kelly Johnson's team. And if we take a look at how this compares to the tenets of Agile, we see that it matches very well. A shared, robust vision that is able to adapt to change with whole teams that are doing incremental delivery and continuous testing and integration. They mirror exactly the principles that were in Kelly Johnson's Skunkworks program, and Skunkworks continues to deliver with success today. Now, this next program is actually one that I was on, and I ran this program for about 4 years when I was at working for Booz Allen Hamilton at CNIC. CNIC is the Commander Navy Installations Command for the Navy. It's kind of funny, it's got Navy in the name twice. This is a branch of the Navy that invests in its facilities in order to reduce the energy use and also to switch from brown power to green power. Now, this program was all about picking the best projects. So the way that this worked is that first projects were sent to the headquarters inside of templates. Those templates would then evaluate the projects based upon a hierarchy of criteria that would produce scores like net present value, energy savings, the production of new enabling infrastructure for future projects. And after it went through our optimization formula, we would come up with which projects were good and should go ahead and get funded, which projects needed to be taken a look at again, and then which projects were just bad and they were never going to get funded. The output was a selection of the best projects and the rejection of those that didn't meet muster. And of course, only the best projects would get the money. Now, in terms of the basics of this program and what you should know, this was a program for the Navy, and it was run as a contract with Booz Allen Hamilton, where I was a project manager. The scope was to help invest $500 million a year in terms of investments in the shore. Much of that money was through third-party investment, and then about a third of it was through direct investment by the Navy with tax-funded dollars. The cost of the program that we were running, the Decision Support Program, was just $5 million over the course of 4 years, so about $1.25 million per year. We had 2 cross-functional teams of developers and analysts, which included 8 BA personnel and 5 Navy personnel. So this was a small team. But in the end, we were able to produce incredible return on investment. For every dollar they put into our program, the Navy got back $50 in exchange. And the way that we did that was, first, we made the data better and we were able to save $20 million in bad projects, followed by we were then able to improve the selection of projects so that we were able to gain an additional $30 million in revenue in terms of saving energy costs. And from there, we were then able to identify and continue to improve the cycle of investment with additional modeling to identify the next project, as well as to track the project success. Now let's talk about projects that are even greater scale. We're going to go from the Air Force with supercomputers to NASA and its spacecraft. First off, the Air Force built one of the most powerful high-performance computers, the Condor cluster. This Condor cluster strung together PS3s with over 2 million miles of cable. As a result, it was extremely efficient and very powerful, able to be flexibly put together in a lab. And it could even be put on a plane. This allowed for the real-time processing of imagery for operators in the field that had never been provided before. In fact, they were able to go from days of processing time to seconds. And so that actionable intelligence was given to operators so they could use it in real time. Then there's the NASA missions under the Faster, Better, Cheaper initiative. In total, there were about 10 successful missions during this time, but two that really stand out are, first, the Stardust mission, a mission which slungshot a spacecraft around the Earth and then around the Sun so that it could trail and catch the stardust coming off of a comet, as well as Shoemaker, which was actually a spacecraft that was intended to fly by an asteroid, but it landed on the asteroid instead, taking high-density readings that had never been thought possible. Both of these missions were done under budget for a tenth of what it costs to do a mission today, using Agile principles. And because of the reuse and because of the ability to limit scope during development, NASA was able to produce many working missions, 10 working missions, for the cost of one that it costs today. So I hope that these examples have inspired you and given you some good food for thought. It should be able to allow you to talk about Agile and its success in any context. I look forward to seeing you in the next lesson.